Hello and welcome to this lesson on tree diagrams. If you want to put today's date and the title and have a go at the do now slide and resume playing the video when you want to go through the answers. So it asks you to copy and complete the diagram for the event, the difference between the scores when two fair six-sided dice are thrown. So that just means the difference between the two numbers on the dice. So you subtract the smaller score from the bigger score. So here along the top we have the numbers 1 to 6 that you may get on the first dice, and down the side in this column here we've got the numbers 1 to 6 that you might get on the second dice. So the difference between the two numbers, if I get a 1 on the second dice and a 1 on the first dice, 1 subtract 1, I have a difference of 0. So if I get 2 on the first dice and a 1 on the second dice, I will get a difference of 1, and so on. So hopefully you filled in the table and you've got these as your answers. You probably also notice that there is a pattern as you're filling them in. So we're going up obviously in ones here. We've got a difference of 1 here because we can't have a negative difference. We haven't got negative numbers here, so we can see the pattern. Then it asked for the event described, find the probability that the difference is 1. So there are 36 outcomes altogether. The probability of you getting a 1 is 1, 2, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 10 out of 36, which cancels down to 5/18. The difference of being 0, hopefully you got 6/36, which cancels to 1/6. A difference of 4, hopefully you got 4/36, which cancels down to 1/9. A difference of 6, so hopefully you noticed there were no differences of 6, so this was impossible, so this gave a probability of 0. And party that the difference is an odd number is half of the outcomes, 18/36, which is 1/2. So today we are going to look at tree diagrams. So hopefully by the end of this lesson you will understand what a frequency tree diagram is and also what a probability tree diagram is. And we're going to look at using probability tree diagrams to work out the probabilities involved in combined events, which is what we've looked at last lesson. So our success criteria then, our bronze objective is to be able to complete a frequency tree, and we'll look at an example of that next. Our silver objective is be able to draw a probability tree diagram and notice the differences between the two. And our gold objective is be able to work out the probability of combined events using the tree diagram. So frequency tree diagrams then, let's have a look at this example here. Suppose a bag contains coloured discs. You are going to take discs at random from the bag. The probability of taking a red disc is 1/8. The probability of taking a blue disc is 1/4. And the probability of taking a green disc is 5/8. You take a disc and then replace it. So you're going to pop it back into the bag and you do it 80 times. How many discs of each colour would you expect to take? So the probability of a red was 1/8. Remember, to work out an expected value or an expectation, you do the probability multiplied by the number of times the event takes place. In this case, the event is selecting at random a disc from the bag, and we are doing this 80 times. So the probability of a red is 1/8. So 1/8 multiplied by 80 would mean that we would draw 10 red discs from the bag. And this is theoretical probability, so this is what you would expect. Probability of picking a blue from the information was 1/4. So 1/4 multiplied by 80 would mean we would expect to pick 20 blue discs from the bag. The probability of a green disc was 5/8, so we would expect 5/8 multiplied by 80 to get 50 green discs. Check that these three add back up to 80, which they do. and then we can represent this on a frequency tree diagram. So this is a frequency tree diagram. So we have ovals with the total numbers in. So the total number of discs to start with was 80. And then we have the branches coming off, which represent the red discs, the blue disc, the green disc. And we write the frequencies at the end of each of the branches. So we'd expect to get 10 red, 20 blue and 50 green. So this is quite a basic frequency tree diagram. Let's have a look at a more complicated setup of one. So example 2, 400 people take a 2-part test. In the first part of the test, the probability that someone passes is 0.8. In the second part of the test, the probability that someone passes is 0.6. Show the outcomes on a frequency tree. So it doesn't talk about a probability tree, it talks about a frequency tree. So we are just wanting to show the total values in ovals kind of at the beginning of the branch for the total to start with, so that will be the 400 people, and then the values in each. So if I just show you this here, we're going to start with the 400, and then from this they either pass or fail. So to work out the number that pass, the probability in the first part that someone passes is 0.8. So remember, it's the probability multiplied by the number of times that event takes place. So 400 people took part in the test. So 400 times 0.8 would mean that 320 pass. So 320 pass would mean then, by looking at the totals that I've got to add back up to 400, would mean that 80 fail. Going back to the information, so on the second part then, if I go back to my tree diagram, so pass fail, this is the first part, and this represents the second part. So the second part, we're going to have then 2 options coming off each of the pass and fail, because somebody could have passed the first part and then either passed or failed the second part, or they could have failed the first part and either passed or failed the second part. So to work out the answers for the second part, so we were told in the second part the probability that somebody passes is 0.6. So 0.6 multiplied by the 80 that passed, this is this one. So 0.6 multiplied by 80 would give me that 48 would pass the second part. And then I just need to take this from 82 to work out that 32 would fail. Again, 0.6 will pass in the second part. If we take the 320 now, 320 multiplied by 0.6 would give me that 192 pass. I can subtract this then from the 320 and it will give me that 128 fail. So the exercise today then, the first question is to do with frequency trees. This is a more straightforward one in the fact that you just need to read through the text information that you have here and just work out where the values need to go. If you want to pause while you have a go at it, and hopefully this is the result you should have ended up with. So now let's have a look at a probability tree diagram. So a probability tree diagram is slightly different from a frequency tree. So probability, it's the same setup with the branches going along, but what we tend to do is on the branches we write the probabilities of the events happening, and then at the end we say what they are. So let's have a read through this question and see how it works. So a bag contains 5 red counters and 3 white counters. So there's 8 counters altogether. Sarah takes a counter at random from the bag. She notes its colour and replaces it. So that would mean that these events are independent of each other. They won't affect each other. So they'll be out of the same amount because we're replacing it into the bag. We're not changing the amount of counters each time Sarah takes one from the bag. So Rosie then takes a counter at random from the bag. Complete the probability tree diagram. So on the first branch then, we have Sarah's pick, and Sarah can pick either a white counter or a red counter. So we write this at the end of the line, at the end of the branch. So the probability that she takes a red one where with the 5 counters out of the 8 in total, so 5 eighths. Probability of a white counter, 3 out of the 8th, so this would be 3 eighths. So when we have got this branch here, note that these 2 probabilities must add up to a whole one. So 5 eighths plus 3 eighths is 8 eighths, which is 1. Then we move on. So if Sarah picked a white from the bag and puts it back in, well, Rosie can still pick a white or a red, which is why then we have 2 options coming off here. But also we need to look at the other possibility that if Sarah picked out a red counter, Rosie could still pick out a white or a red counter. So the probability now that Rosie picks a white counter, well, Sarah replaced the white counter, so there's still a chance of 3 in 8, 3 eighths that Rosie picks a white. And there's still a chance of 5 eighths that Rosie picks a red. And the probabilities are then the same here. So if she picks a red, the chance of her still picking a white on the second pick is 3 eighths, and a red is 5 eighths. Normally in an exam question, they ask you to complete the probability tree diagram normally for 2 or 3 marks, and this is what you would do. You would fill in the probabilities on the branches. Now then, it asks us to work out the probability that both Sarah and Rosie take a red counter. Now that means that I want this option here. I want Sarah to have taken a red counter, and I want Rosie to have taken a red counter. Now remember, if I want a probability of something and something happening, the and rule of probability is that I multiply them together. Whenever I am working across a tree diagram, I want this event and this event to happen. I want them both to happen. So I multiply the probabilities together. So 5 eighths multiplied by 5 eighths. Remember, when you're multiplying fractions, you would just multiply the numerators and multiply the denominators. So you will get 5 eighths multiplied by 5 eighths, so you will get 25 64ths. You could then cancel this down if you can do. Part C, work out the probability that only one of the counters taken is red. Now this lends itself to having 2 options here. Now here they're both white, so I don't want this option. But for one of the counters to be red, I could have a white, then a red. So it could be this option, but also it could be this option. It could be the other way round, red, then white. So actually I want to work out the probability of white and then red, the probability of red and white, and then I want a combined probability. So it means I want this or this. So I will add these together. So that means a white followed by a red would be one of them red. So 3 eighths multiplied by 5 eighths, and putting it into brackets lays it out nicely here. And then the other option, I could have picked a red then a white. So this is the other combination here, and I'm going to add them together because I want this or this. So this is 15 over 64 plus 15 over 64, which will give me 30 64ths, which will cancel down to 15 32ths. So now it's your turn. Have a go at the rest of the questions from the textbook. Have a read through question 2. You have the tree diagram here started for you, and then that's the questions from it. And these are the answers. So if you work through the questions, so question 3 is here, and then the answers. Question 4 along with the answer. Question 5 and the answer. Question 6 and the answer. Question 7 and the answer. 8, 9 and 10 with the answers. Now you don't need to answer all of these, and it may be that you want to just go along and work through the Hegarty tasks that that are set for you on the sheet this week. Let's have a look at some true or false questions. So a frequency tree has the frequency totals filled in at the end of each branch. Well, yes, remember this is true. A probability tree has the probabilities filled in above each branch. So yes, again, this is true. We use the OR rule where we add the probabilities working across a tree diagram. No, this is false. Remember, when we're going across the tree diagram, we want this option and this option. So this means we multiply them going across the tree diagram. So we use the AND rule, so we multiply to combine events in a tree diagram. No, this is also false. Remember, when we want this event or this event happening, so when we're looking at the events and combining them, this is when we add them together. So as a bit of a recap of that then, if you can write these two down into your book, so these are the AND the OR rule of probability, and we'll look at them again more closely in the next video lesson. So the probability of an event and another event happening is the probability of A times B. Remember, this is going across a tree diagram. The probability of A or B happening, so this could be a combination of the events that are at the end, is the probability of A added to the probability of B. Make sure you've got those copied down.